Okay, before we start the constructions that you need to know, there's videos for each of these at pcalearning.net/maths/presmaths4.htm. So if you go there anytime, you'll find all the videos of all the constructions that you need for the Leaving Cert course. Okay. But you really need to know. You need to know all of them, but you really need to know how to construct a triangle given three lengths, how to construct the perpendicular bisector of a line segment, and how to bisect an angle. Okay, because if you know these will help you to find and construct the circumcenter and the circumcircle of triangles, the incenter and the incircle of triangles, and the median and the centroid of a triangle. These are all the main parts of this chapter. And before we look at those, or as we look at those, let's look at some common terms and terminology. So a tangent, if we recall from the geometry chapter, previous geometry chapters, is a line perpendicular to the radius of a circle. Okay, so a tangent touches the circle at one point, and it's actually at 90 degrees to the radius of the circle. That radius from the centre of the circle to that point, that tangent point. And the tangent point is the one point where a tangent touches the circle. So a circumcircle, what is a circumcircle? Well, the circumcircle of a triangle is the circle which passes through the three vertices of the triangle. Okay, so for that triangle, that's the circumcircle because it touches all three vertices of the triangle. And the circumcenter of the circle is actually the center of that circle. Okay, and funnily enough, it's always, if you have a right-angled triangle in a circle, the center is always the midpoint of the hypotenuse. Might not look at there, but that's where it is. The incircle then is a circle in a triangle. Okay, so it's the largest circle that can fit inside a triangle, and actually it touches the triangle at 3 points. Three points at three, if you like, really three tangent points. If you imagine the three sides of the triangles as three tangents. And the incenter of the triangle is at the center of the circle. The incenter is at the center of the incircle. This is the incircle and this is the incenter. This is the circumcircle and this is the circumcenter. Equidistance, what's that mean? It means the same distance. And we met in this chapter the fact that any point on the bisector of an angle is equidistant from the two lines forming the angle. So if we have an angle here and we bisect it in two, any point here along this bisector is equidistant from both the lines that form the angle. Same distance, same distance, same distance, same distance, any point you like. Okay? And then we met with the median. The median is the line segment joining the vertex of a triangle, like this vertex here, to the midpoint of the opposite side. So this is a median, this is a median, and this is a median. And the centroid of a triangle, the centroid is the point of intersection of the three medians. So if I had three medians drawn, and this was point G, G is the centroid of the triangle. And if we look at some interesting construction applications, this question 12 from page 446 of your book, the diagram, if I just enlarge this as much as I can so you can see it all. The diagram, this diagram here, shows three villages, Drum, Moor and Tubber. The distances between the villages are shown, so 6.5, 6 and 4. Using the scale 1 centimetre is 1 kilometre, Draw an accurate diagram of the triangle. And note that it's planned to build a school equidistant, same distance from each of the 3 villages. Show where the school should be built. Well, to draw an accurate version of that triangle, take any line you like, but I'll take this line as my baseline, and I'll measure 6 and mark 2 points here, 6 apart. I'll take my my compass, and I'll measure 4 centimeters on the compass, and I'll strike an arc there, and I'll take my compass again and I'll measure 6.5 for this side here, and I'll strike an arc there, holding one part of the compass there. I'll strike that arc, and that is the vertex at the triangle there. Okay, so this reproduced in your copy, as it were. And then we need to find the circumcenter of the circumcircle of the triangle, because as if we can somehow fit this into the circle, then if we find the circumcenter, each point is a radius away from the center of the circle. Okay, so as all vertices on the circle are equal distance, a radius length from the center where the school should be built. So basically what we need to do there is to use your construction to find the intersection of 2 perpendicular bisectors. Okay, so to find the circle, if you're given a triangle, okay, you find the bisector of this line, say, and the bisector of that line, and that is the circumcenter of the circumcircle. And the intersection of those tells you where the school should be built. And let's look at question 16. 3 people at point A, B and C on a shoreline see a boat at sea. Okay, so there's a boat somewhere out to sea. Here's the 3 people at points A, B and C. The boat is the same distance from all 3 people. Describe how you'd find the position of the boat. Well, the answer again is quite similar to the other one, in that the boat will be at the circumcenter of the circumcircle of the triangle ABC, as each person will be at the vertex of the triangle, and they will be equidistant, or the radius length from the center of the circle. So here is our triangle for ABC, and we find the perpendicular bisector of 2 sides. So that's for AC, and this one is for BC, and where they intersect is the circumcenter of that circle that the 3 points are on. So they're all a radius length away. The boat, is a radius length away from points A, B and C.